Yeah, so hello. So using decentralized storage and plausibly deniable storage all together. So today's talk, I present a RECO code in which we add a layer of redundancy to plausibly deniable storage tools like Shuffle Cake. In another track of my research, I have been working on encoding data for achieving high fault tolerance, improving data integrity, and also anti-censorship, because basically what you see here is like 3 different ways of increasing the redundancy of systems. And so the blue chunks are like the data, the information. The others are redundant information that is generated by different type of redundancy systems, and in one case it's replication. Basically what you're seeing is like how many paths you will have to read data. Well, replications, if you have 3 copies, you will have 3 different ways of reading data. In erasure coding techniques, traditional erasure coding techniques, you will have different paths. Some are virtual paths because basically redundancy made with erasure coding is very efficient in terms of space. But you always need to read a large number of blocks when reading. And these are entanglements. Entanglements, the original idea of entanglements, it was in 2000. It was for a Tangler, an anti-censorship system. And basically the main idea was to create a conundrum in which data that is maybe legal and data that is may not be legal in some places in some systems are merged together. And during my PhD, I was working on this for actually to create redundancy, to improve fault tolerance actually in the cloud. But yeah, we realized that this can work in many places. And the idea was to create also a system that is doing in a practical way, because previous algorithms to entangle data wasn't practical. They were like, okay, you have a data block and you need to merge with all the blocks in the system, and and make an operation to all the blocks in the system. That's not practical. So these alpha entanglements work like, as I explained very briefly today, like simple entanglements, except that every data that is added to the system participates in alpha chains. And then every data block that is in a system is basically merged in a way that it creates different concentric paths with less or more blocks that basically can be used depending, or either like to create multiple ways to read the data, or also if there is a failure that affects many blocks, you may use paths that require more blocks to read, but if the failure is small, you can read it with less. Another thing that I have been working on is on protecting trees, like Merkle trees, because these are used, tree structures are used in decentralized storage systems to locate data in the decentralized storage system or to verify the integrity of the data. And if basically on the left, you have just a simple binary tree where normally the root may be stored in a blockchain and all the intermediate nodes and the data itself is stored off-chain. And when it's stored off-chain in a peer-to-peer network, you need some redundancy to protect these blocks, but normally there's different situations. In some cases, the data is replicated, so only the leaves and the other part is ignored. So then these chunks are lost, and then data is not available anymore. And then on the right, you see we had a cluster with 1,000 nodes, and of the Swarm network that is kind of an equivalent of IPFS, but more focused on actually on censorship, anti-censorship, and privacy issues. And we see that in this case, chunks. So this is a radial visualization of 128 every tree. That means that that every intermediate nodes may have up to 128 branches. And basically what we see, and in the center we have the root, and we see that some chunks get more replicated, the ones with with more darker edges means that are replicated more, I think. And this is a different, much easier way to read it, perhaps, the relative chain replication. So basically, the number of replicas per each block varies a lot. That means that if some of the intermediate nodes are lost, yeah, everything is done. And why I explain all this? I mean, because the idea, the long-term idea is like to combine the record code with decentralized storage systems and to protect data, but also in a decentralized way. And yeah, I wanted to mention this. So if you're interested in this kind of solutions, I would like to know what will be a use case. I don't know, like for instance, to store the bootstrapping information to accessing the Tor or something else. I don't know. I mean, that's I would like to know a bit more from you. How would you be interested to use this?